All right. Yes, yes. There's one thing that will always stick with me. Is that too ringy for y'all? Sorry. All right. Somebody walked up to me after our presentation and goes like, that was very interesting. I don't think I understood anything, but at least I was entertained. So hopefully what we're going to do is we're going to try to hit at least one of those areas. And ideally, it's life-changing, in my opinion. All right. Thank you all. My name is Norm. You've heard me referenced a variety of different times in good and bad contexts throughout the conference. But I've been a LabVIEW member of the community since about 99, so 24 years doing this, which is a little crazy. I do RF stuff and LabVIEW stuff. I cut my teeth with LabVIEW. I went to school in Milwaukee. I was the guy who took that 1 week lab in LabVIEW and all of a sudden started doing the TA's job because I got it and I liked it and everything else. And it's just been going from there. And I learned RF the hard way. And I also have learned a lot of lessons by experimenting with LabVIEW over the years. And one of the things that I want to do is I want to transform y'all's perspective to make other people's lives better with this concept. DFD, designed for reality. That's not a typo. It's intended to be an eye catcher, but the idea is it's designed for debug, tactics and principles for design for debug. Somebody told me a long time ago it was when presenting, make a promise. You're giving me your time and your attention to some varying degrees, of course, after lunch. But I want to promise that you will walk away with a newfound, let's see, I'm going to read, make sure I get it right. Newfound enthusiasm and skills for proactively augmenting your development with a mindful compassion towards the person who needs to debug your code, your system, which, of course, as we know, that might be you, right? So I will start off with a controversial statement that I'll steal from, I think, Omar Musa, an ex-Virgin Orbit employee. He said, debugging is a waste of time. Now, some of you may hear this phrase and go, heck yeah, nope, I know exactly what you're talking about, yes. And other people are like, what are you talking about? And you're ready for some fighting words. So let me bring a little bit of clarification for what design for debug is. It is explicit design choices which intentionally enable or accelerate the inevitable process of debugging, right? We all program. As the adage says, the only VI with no bugs is a blank block diagram, right? So we all make things, right? No matter what we've done, right? Hi, my name's Norm, and I write bugs, right? It's reality, right? That's how it goes. And as we know, it's also inevitable, right? It's just the way that it goes. It doesn't make a difference what kind of new fancy architectures you're using, whether it's DQMH or TLB prime for one guy in Korea. And, for whatever the situation is, there's the whole backstory there. No need to tangent at this point. But the reality is like, so I pose to you a choice, right? We know that we make bugs. We know that spending time fixing your bugs, and let me clarify that statement, let me just maybe go back a little bit. Fixing your bugs is not what you want to be doing, right? You're supposed to be doing and making a thing to help other people do whatever it is, or your own thing. Get insights, do tests, controls, RF, whatever it is. But if you're spending time debugging, that's not getting closer to the final solution. You're effectively going backwards in time, spending time trying to figure out why the bug exists, and then fixing it, and then moving forward from that point, right? So let's make a choice, right? What are we gonna do about that? Well, I say we have one choice. We can design for debug. We'll talk about the whole design for, design driven, yada, yada. But I would say that is a designing for reality. If we all know fundamentally from the beginning of time when we started making code till now, people are constantly writing bugs, but people don't talk about making that better. Everybody's trying to patch it, trying to prevent them from existing in the first place, but we know it's going to happen. Let's be realistic. Let's do things that are going to make that process easier. Or we can just say, this is fine, right? And we can keep going. And it's not that we're not trying to get better and trying to do better things, but I would say if we start investing over here, people's lives are going to be better. So why do we waste time? Let's talk about this a little bit, right? Why do these bugs happen? Well, one, we program for the happy path, right? We write a program that does the thing that it's supposed to up until the point that it doesn't. And we don't spend a lot of time necessarily trying to make our programs more robust to prevent that eventual collision from happening, right? We make the program work the way it's supposed to, and in the worst case, the minute that the run arrow's not broken, ship it, right? We've all probably run across that type of attitude in a variety of different ways for a variety of different reasons. Usually it's for this reason. We want to go fast. We're all underneath a variety of different time constraints to get the stuff out the door, right? Get the test information. Everything else took so much longer than expected, so now instead of having 3 months, we've got 3 days to test our product, right? These are just realities that we deal with. And so I've got empathy, right? I know how this goes. Another one, this is another thing. We fail to accept the fact that we're not perfect very often. Once again, another admittal. Hi, my name is Norm. I'm not perfect in a variety of different ways. And so I'm going to make these things. So let's stop pretending like the code that we make after it runs and we ship it the first time, or we build it in an executable and it does this, it's going to be good to go. And Steve Watts, where are you, Steve? Steve, can you read this quote really, really loud?
It runs, it's good.
David Corney is a member
it's all
of...
bloody well and good.
Yes, it's all bloody well and good till something stops working. David Corney is a member of the community and also a member of technical support engineering at NI. And there was an iconic quote that as I was talking about this, he mentioned that and he said that and he's from the UK. But that reality of it's like, hey, we're all good. And then all of a sudden crap hits the fan. And then what do we do from there? So I would pose this question. What would you like to be doing? Right? What is the thing that you would like to be doing with your job? Do you want to be creating something monumental or even smaller? It doesn't have to be some crazy monument out in the Black Rock Hills of North Dakota or wherever. But we want to make things, right? We're creators, right? We like to fix things too, right? There's a paradigm. Do I like to create or do I like to fix? Sam said it, and Darren, you know what I'm talking about. What's the name?
Maker versus Mender.
Maker versus Mender, right? There's maker versus Mender, and to some degree there might be some ground in the middle we can talk about. But I think we all have this essence enough. We like problem solving, but we also like to have good things come out of it. Or do we want to do this? Right? Oh, don't even say, we know, we've seen these diagrams, right? But what do you do? I mean, that poor schlub is there trying to reverse engineer where all those wires are going from. He's seen some problem and trying to reverse engineer what it is, right? And that's what we do a lot of times. Or that's, more importantly, that's what we cause someone else to do, right? There's a reason that you might see me carrying these little guys around. I just got them for my twin daughters, 4.5, they're awesome. But less important than that, I don't want to spend time trying to debug that mess over there. Now, you might not have kids, but there's more important things than probably even that fun stuff that exists out there. And when you do something that inherently makes it hard and it wastes somebody's time, you're preventing them from doing something cool or the more important things that are out in the world. Right? And if we don't think about that, if we don't carry that in our hearts, right? If we're not conscientious about that, we're like, do my thing. I'm going to be a creative LabVIEW coder. I'm going to use event callbacks. And anyways, long story. But yeah, see if you can carry that with you, right? All right. So why is there this time suck in general? And why do some people do it faster than others? Right? Like Darren and me, there's certain stuff. Like for me, I do RF stuff, and I can look at a spectrum and go, there's your problem right there. You're got the wrong frequency signal. I can look at a complex spectrum and go. But the reality is clues, right? There are certain people like Darren, myself, and I'm probably a variety of you out here that can just take a whiff or a look at a block diagram and go, that's why this problem exists. It happens to me on a very regular basis, and I'm pretty good at it, but it's because I can see the clues. So because I have this instinct, I have this sniff test, because I've made those observations. What's Sherlock Holmes known for? Walking up to a thing and going, it's like, oh, you've got some schmoo on your shoe, and I know what to do in rhyme, apparently. But also for us as engineers, we know, like, hey, if I wiggle this over here and that starts twitching over there, oh, you've got this problem in your code, right? It's a race condition. You've got here's a fun one. You've got an extra white space character in a string, right? How many of us have run into that one before? Yeah, exactly, right? It's like that string is fine, so there's got to be something else, right? But we also have that, why did we all raise our hands? Because I asked who did it before, because we have historical knowledge. But what about the people who were in that one bar where it's like, I've been doing this for 1 to 6 years? What kind of historical knowledge do they have? Yes, exactly, or less. But we also have this systematic understanding of how things work. This is the stuff that I would say makes us good. Like, for those of us who have been programming with LabVIEW, we know how to think in LabVIEW. We kind of get an idea of how the compiler does what it do. So when something goes goofy, we'd be like, wait a minute, that's probably something memory glitchy. Oh, wait a minute, I acquired 10 million points, and so all of a sudden the memory allocation's blowing up, right? We kind of get the feeling. But for you, as you're working with your frameworks, your architectures, your programs, the VI architecture, as we mentioned yesterday, right? You have this systematic understanding for the moment. But the reality is that future you is going to be way more clueless, or the next person along the way, right? So even though you're good and you're making stuff that you think is pretty darn good and better than everybody else's, you're probably going to end up needing to spend time on it in the future. Okay, so we're about to get into some meat, but hopefully, if you're still not sold on this mental model, right? I'm trying to get your headspace squared off, right? Even with new techniques, test-driven design, all the driven stuff that we were hearing from Jorg and from Steve about, right? All of these things, object-oriented programming, interfaces, Rust, whatever, we're still making bugs. It's never going away, folks. It's a constant in nature. Tell me I'm wrong. Anybody's like, yeah, I was gonna say, like, where's my coffee? We're all gonna make bugs, change my mind, right? If you know the meme, it should be funny. All right. But if you're spending I'm going to read this verbatim. If you're spending ample time trying to track down a problem, you can improve your system, and likely should, right? We're all going to go back to work at some point in time, hopefully, unless those of you are, and you're going to run into a problem. As you're solving the problem, take mental notes of what are you doing to solve this problem? And how can you make that faster so you next time you waste less time or have somebody else? So this is another one of those fundamental things that if you hold in your heart, I think you'll do better. Not facilitating good debugging is a technical debt issue. Let me prove it to you. Bugs equal technical debt, right? It's just something that shouldn't be in your code the way that it is, and at some point in time, it's going to need to be addressed, right? You've taken out a loan, and you'll have to pay off that principal. Time spent finding the problem is paying off the interest. So if you take out a loan, right, credit card or house, what do you pay first when you pay the bank? You pay the interest down. And then once the interest is paid down, then you start notching away at the principal. Ever so small slices of your 30-year mortgage at a time, right? And so, fixing the issue, of course, is paying off the principal. You put a bug in there, you remove the bug. But the worse that your debugging scenario is for the rest of the world or for some schlub, that is high interest rates. What are the high interest rates on your technical debt that you are putting in your code? I'm getting pointy here at all of you, not because I don't do it, because we should all take this internally. That is high interest rates, right? For things that we'll demonstrate here shortly, there's a lot of nice stuff that DQMH, its consortium, Darren and Fabiola, have put into that framework and things over time, along with other people. But they've done what they could to lower that interest rate. Can't get rid of your bugs. We will all still make them, right? All right, test-driven design and design for test. Let me see if I go. All right, so I'm gonna hide that for just a brief moment since we already had some discussion about it. The word driven. If you hear test-driven design or test-driven development, that means you are active, in my perspective of the matter that you heard about first thing yesterday is, you are changing the way that you develop and you move forward down the road by testing, by having tests, right? You create your test suite up front, and then you do the rest of your development, and you notch off each one of those tests over time. And so your development is being driven by test, right? And what I would say that design for debug is more of that you're actively manipulating your design to enable and have extra things part of your design to facilitate the debug. So I'm not saying that design for test is bad, and I'm not saying that they're completely mutually exclusive for those of you who do TDD, but I'm saying there's a healthy amount of problems in your code that can and will be addressed by the design for debug paradigm. And that's why I take the driven out of it and I say design for debug. All right. Let's see if I can compare two different QMHs, both written by our beloved Darren Nattinger over here, that are the continuous measurement and logging. It's the example program in LabVIEW, or the example project. Get it over here. Let's see. Let's find the right project. There we go. All right. Come on. There we go. I'm going to stop this in the background. Use that in a moment. Make that bigger. Over here. There we go. No, this is not LabVIEW 2023. You'll hear about what this is, the zooming thing later. In this program, as it currently stands, if there's a problem, what does this incarnation of a queued message handler do for you to ease the burden of needing to debug problems?
Not much.
Not much is the right answer. But you get probes, right? What would you do? Go to the block diagram. Well, one, you'd have that wiggle it here and see that kind of behavior. Maybe you can get something from that front panel interface. Heaven help you if it's an executable, right? You can maybe probe some things with the standard default probes and maybe get some insight as to what's going on. But out of the bag, you don't get much. It still works, right? It's not a broken run arrow. It's a clean diagram, right? Everybody emulate what Darren does except the small little, anyways. Sorry, I take umbrage with having like 300 by 400 pixels in this main section right there. It's a different story. But the reality ends up being is that there's very little, if nothing, put into this to aid us in the process of debugging. It's not that we can't debug it, but it takes extra effort. Contrast, before I do, pro life tip, if you press Control-Shift-W, you get this lovely dialog that's called All Windows, and then you can sort things and you can find stuff very easy instead of going through your Windows taskbar and things of that nature. It's existed in LabVIEW forever and a day. You can find it here, right there. Oh, I'm getting ringy. Sorry, right? Control-Shift-W. In any case, very handy tool for, hey, I've got a lot of stuff open and I need to get to what I need to. I need to accelerate. We'll talk about that in a moment here.
Hey, Norm,
yes, sir.
I'm the one that's supposed to tell them about the cool stuff, not you.
Well, you'll tell them more, and more cohesive words probably too. I gotta use my computer. Okay. There we go. I'm gonna go right here. We'll make this work. We're good. And, there we go. There, sideways. There we go. I can do that. All right, so let me get to the right project of interest for the moment. If my computer lets, oh no. Everything is broken. There we go. All right, so once again, we're back here, get to there. I'm going to go to the project for the DQMH incarnation of the queued message handler. And I'm going to run this program for which you cannot see many things, but hopefully you can tell very quickly that this is not the actual continuous measurement logging program itself. This is the launcher for it, right? So we're already one step up. There we go. So we ran the launcher and we have this thing that calibrates and starts. I'm clicking some buttons down here and you see a signal. There's really nothing glorious about the program that does all that much different from what we were seeing before, except you may have noticed in the background, not that dissimilar to some of the things that TestDirects were showing in their how, we have some insights as to what happened in the program. right? There was the calibration. There you go. Device, can you see that in the back? I tried, is that like a good, yes, all right, it's readable in the back, which is great. Device successfully calibrated, right? And you can see those order of operations, right? So if you know, what happened? Did something happen before or afterwards, right? This is already one step that you've got in here. Not only do you have something like this within the module where you have some basic logging information, there are other tools that have been built on top of it, like the Panther dashboard that we'll showcase a little bit later. But I would say that, would you say that this is probably, let's see, we can stop the module, start the module. I think there's some, what else we can't do anything else from here, but something else that exists, let me open up one of the modules, the acquisition module that has, testers, hold on a second. One of the nice things about DQMH, it has that every module has a tester paradigm that goes along with it. Y'all can see that there, right? So I'm gonna open up my test logger API, and even though my program's already running, I'm going to do some things. I can show the module panel. I can show the block diagram, right? Hopefully you can look up settings that are part of the panel. You're getting also a log of the information. This is not for you to necessarily take notes on, but from a standpoint of a thing that's out in the world that inherently has lowered that interest rate substantially when things go wrong, I would say that this pretty well qualifies as doing a lot of work, right? Does anybody inherently disagree? Okay, terrific, thank you. All right, now there's a matter of properly stopping everybody, which is not my forte quite yet. Hold on, get there. Make sure I close it all. It bit me last time. Okay, so none versus good design. For those of you who can see, example comparing difficulty, none versus good, right? All right, so we're gonna get techniques for everybody. You're gonna get a technique, you're gonna get a technique, you're gonna get a technique. This is gonna be wonderful. All right, and it doesn't matter who you are is it Pokemon evolution? Like that's what they do when they move bigger? I don't know, it was after my time. But in general, we're gonna talk to I wanna give techniques for level 1 users, people who is basically a person, a bench, a license, and go to town, right? You can do design for debug even at that basic level. Of course, if you are a level 2 developers, I would say you are building on the shoulders of others and to build your larger systems, right? You're using somebody else's DQMH, actor framework, this, that, or the other. Once again, TLB Prime for a guy in Korea. Or level 3 architects, you're making stuff for others. Now, of course, we have a variety of people in the room that are at that level 3, but I think based on the survey from yesterday, we're covering the gamut, right? We've got skills of all things. So let's talk about this. All right, so what do we provide to the future? Because they might know where you live, right? Hold that, right? We need to give the future 2 things. And I'm gonna split it for these first 6 tables and then the rest of the room, all right? 2 things we need to give to the world. 1, insight. 2, accelerators. Right? Say it with me. We're gonna talk about what they are in a minute, but the first 6 tables.
Insight. Accelerators. Insight. Accelerators. Insight. Accelerators.
Perfect, good. That would be really, really weird. I was wondering if Steve was hiding behind the screen again. All right. So we need to give the world insights and accelerators, and let's talk about what those things are. A simplified example, I would say, is kind of like Wordle, right? It took the world by storm. It was really fun, and now we don't see it anymore. Whatever. But what did we get? You put in some information, and you get some clues out on the other side. This word, this letter is used, or this letter is used and in the right position, right? That's insights, right? And then the idea of accelerators. Yeah, where's Kevin in the back? Give me a good, that's got layers.
Onions.
It's got, no, the onion's got layers. In your proper Shrek speed, yeah, that's okay. In any case. But the reason that I put this up there is because what happens when we have a program with substantial complexity and we're trying to get down to the VI that has the problem and we're opening and we're opening and we're opening and we're opening and we know where the problem is, right? We pretty much know exactly where the VI is that's actually the culprit, but what do? We drill through the layers. Well, an accelerator would be something that takes us to the problem faster, right? So insights, information, and accelerators, things to leverage that insights and get to the problem quicker. Sorry, can you see? There, okay, cool. All right, so let's talk about a couple different levels, and I'm gonna try to do some demos with reasonable amount of time. Get the cell phone out. All right, halfway through. Yeah, totally got time. Go here, and let's focus on those first three that exist right there, right? So if you're a level 1 programmer, I would say who here would consider themselves a level 1 programmer? Let's just do a quick survey. I mean, I'm outing everybody that put their, was in that 6 people or whatever else, right? That's your level 1 programmer. Who here has actively made and leverages custom probes? Okay, oh, yes, okay, terrific. Well, wonderful. Then encourage other people to use them as well. So you know what they are. I will show you an incarnation of a custom probe that maybe takes it pretty far down the road. If I go to, so I do RF. It's the thing I like to do. Hold on a second. I need to get rid of that pen. There we go. So this is a program that's doing RF stuff. Now, if I were to probe, just that data, it's a complex data, oh boy. Where's the probe window? Oops, that's not, I wanted to show the generic one, so let me go ahead and get back to that. Custom probe. By default, without custom probes, this is what you see, all right? Does this type of generic display for something inherently, by definition, complex, for those of you who can't see in the back, it says output complex waveform, complex numbers. Does this give me any insights, right? No, is the short answer, right? There's a very limited amount of information I can gather from that. However, through the usage of a custom probe, I can take that same basic instance and I can, and it's gonna kill me that I can't, anyways, let me go ahead. Sorry, there's, anyways, right? Right? Look, I can see a graph of that tabular information that I had before. What's more useful, right? And this is just one, this is I's complex data, I and Q. I hate I and Q personally. I think about complex data as polar coordinates. And so, look what I got at the top here. I won't say, let me get it. There you go, so people in the back of the room can see, right? Time amplitude, time phase, frequency power. I'm taking that exact same chunk of data and chewing it up in different ways to get different insights to my data, right? If you ever probe something, right, and it's a set of data and you're looking at an array and you're like, wow, it would be way easier for me to look at this digital information as a bunch of hexadecimal characters. Write the probe. Or if you see somebody doing it, encourage them to do it. Because guess what happens? Now you've got a probe that you can reuse. And heck, even if the probe is used, maybe I would say that the reason that most people don't make custom probes is because they're like, well, then I make a custom probe and it's this thing. I gotta get it right. No, you don't. Make it, use it, get rid of it. You may have even seen in my list here, I got, as I probed this, right? I've got one called 1.vi, right? Clearly I was doing some experimenting and it's left behind, but I know the probe that I'm looking for in that pile of things, right? And so just be more free with that leveraging of such a great insight giver. Let's see if I can get back over to different, why is my cursor disappeared? All right, back to that. All right, so let's talk about another aspect of level 1 programming that, once again, it's usable from everybody. Security aside, what would you do if your program just burped out status over the UDP port periodically? Right? What would you, it's like, oh, whoa, hold on a second. Can you do that? Yeah. Right? So once again, security aside, right? I know there's a networking and security and stuff, right? Then you had what was the?
I was thinking Wireshark.
Wireshark. Well, you could use Wireshark, or you could have a whole different program that you write outside of your program listening for those UDP messages. You don't even need a file, right? What's the problem with file-based logging of things that are going on? It grows in size, right? But how nice would it be if you were making a program and you just threw LabVIEW UDP write and you wrote a string about what's going wrong? Or you don't even need to have it in your program by default, but as you're trying to debug your program, you just start dropping these UDP writes, right, with sufficient enough information, right? It's a very simple tactic, right? It's not extremely elegant, it's extremely brute force, really. But at the end of the day, how simple is that? How much insight could you get from a program right? You could even be doing it on a different computer on the network, getting that regular information from your program of interest. I'd say that has the ability to give some really good insight. Okay, now let me see if I can get rid of that. There's that. Cool. Next up, let me just do this. Right? DQMH, API tester. You just saw that earlier. That's a really neat incarnation of, hey, I've got a thing, I want to debug it. We don't need to talk about that. HSD logging, HumpleSoft, from our beloved Humple up front here, yes. There is an entire downloadable package that allows you to do the leveled logging, I think that you were showcasing earlier, and integrating it into your program, and probably a variety of other accelerators to leverage that information in terms of filtering information to the different types of messages and where stuff comes from. Exactly, and Testeract had the same kind of idea. Also, for those of you who are of the active framework cohort out there, there is a, in your project, there is a, if you put a conditional debug flag, conditional disable structure flag, yep, symbol, thank you very much. And we're not gonna detail out what it is because nobody's gonna remember, but it exists out there. You turn this thing on, all of a sudden, all of your actors go, wah! Logging their information into desktop execution trace toolkit for the purpose of, once again, getting insights. What happened when and who was doing it, what happened in the message, and they're all prefixed with relevant information so that you can filter in and filter out those messages, right? You're building on stuff other people have made. In fact, people in this very room make your life and other people's easier just by their existence. Say thank you, everybody. Everybody, 1, 2, 3. Thank you. There you go, exactly, right? And now, however, go there and go, nope, wrong. There we go. Close enough, you get the idea. Level 3, you're making a thing. You don't like using that. You like using other things. Great, then emulate the stuff that they've done, that you've seen, that you've witnessed, that we're talking about here today into the core construct of what you're doing. Once again, like Testeract did with theirs, right? Configurable levels, retaining the last X number of system states and actions, right? Queued message handler, right? If you know what message came in and what the state data, as it were, the data, it is state data, I'm gonna tell you. There's a whole presentation on statefulness. How much could you understand about your program if you knew, here's what it was, here's the message that came in, and what happened, right? We're all kind of doing, even Active Framework is inherently a queued message handler, right? And so getting that kind of insight gives you the ability to replay, to debug, or the idea of bolt-on remote debugging. Inside the ivory towers of NI, right? If something's going wrong with LabVIEW, like really, really bad, right? The LabVIEW team has like, hold on a second, let me drop this DLL in your directory, and now from my desk, I'm going to bolt on my remote debugger to your LabVIEW instance, right? Anybody wants to work at NI? Come talk to me. But the idea is like, you can do that with your programs, right? You can make a thing that allows for a remote system to tap in and get that insight. Way more elegant than the UDP stuff up there, right? This is an idea of insight bringers. There are things that enable insight at the different levels, right? Applies to everybody. Okay, I think I'm doing good. I'll pause for the moment. I'm doing a lot of hand waving. Questions, thoughts? Yes, Mr. Powell.
Hi, Norm.
Hi, Brian.
What are your thoughts on using custom LabVIEW probes for logging?
Custom LabVIEW. Great question. So what is, I don't have to repeat, it's already recorded, wonderful. Custom LabVIEW probes for logging for debug's sake? I love them. I love them, I love them. Now in terms of, I mean, if you think about what a custom probe is, it's a VI, right? It's a VI that's going into your code of interest without modifying it, right? So you do, like, what do we do? Like non-destructive debugging, that's what we want. Because the worst thing you do is you debug the code and the problem goes away, or you debug the code and then you leave another bug behind, right? So the probe itself can give you that information. And I would say in terms of if you're going to do a logged probe, just be mindful of the idea of resetting, you're going to inherently have a buffer of information, and just be careful about the memory growing and growing and growing, and build arrays of memory allocation, and you can end up with a lot of memory by virtue of what the probe is doing. And it will affect timing and things of that nature. But even the idea of UDP logging, right? What did I say a custom probe was? It is a 2-letter word, VI. Great. Throw the UDP right in your custom probe, right? Instantly. You've added UDP logging to your thing. Now you don't have to worry about, once again, security aside, you no longer need to worry about the file size or the buffer size and things of that nature. So I would say these are interesting ways of approaching custom probes to leverage getting you insights more. So that's kind of what you were getting at? Okay, terrific. Yeah, over there. All right, anything else? Yes. I don't know your name. Can you say it again? I forgot.
I'm Eric. Do you ever consider what I call the Heisenberg uncertainty principle?
Heisenbugs, yes, absolutely.
Where whatever you do affects,
Absolutely. Yeah, no, absolutely.
especially on
The
timing
idea,
problems and stuff like that. What do you think of that?
well, it's a great, actually, I don't know if I have it in the next, I forget if it's in the next one or not. There are more intrusive and less intrusive ways of doing some of these things. And I would say that to the degree of logging, something to keep in mind is by having debugging in there from the get-go, like using a logging tool, then it's less destructive or less invasive of a thing when you want to utilize it. So it's good to have it, once again, in your design for debug, great name for a title, that is in there. And also, if you notice that the bug goes away when you change it, and you flip it on and it's not there, and you turn it off and it's not, then you have a pretty good idea that you probably got a race condition somewhere in your code, and ideally you've got other insights that can lead you to why that's happening. So it's not that there's Mandel bugs, right? You go and you just keep going and it gets more complex as you get down into it and never stops being complex, right? There's Heisenbugs, Mandel bugs, and Schrödinger bugs, right? It's both broken and not broken at the same time, right? I think those are the ones you get on Wikipedia. So, there's no getting around it, right? I think we all need to be aware of it. The things that are not intrusive, I would say if you do like a global variable and a queue write, as in like if you want to like keep it in your program and you want something else receiving that information, right? If you had a global variable of a queue reference and you write the information to a queue and there's something else over here sucking the information out of the queue, that's likely to not really hurt that program at that point in time, right? That's an example of one. Probes are pretty invasive because they will inherently, it's like a memory copy, the code kind of waits for the probe to execute. There's like something that LabVIEW does that's a little bit funky. Jörg.
Norm, do we know in which application context a custom probe is being executed?
That's a really good question. I think it's actually in the context of the thing, but I could be wrong. No, it's not. So probably what, like ni.lv.debug? Okay, so great question. For those of you who know what that means, we're not going to get into it now, but beware of the context and reference access. That's a very good point. I want to show one neat thing with the custom probes, or even probes in general, that should allow you to get to information easier, if I can, and have this not fall apart again. Go here, custom probe. There we go, we'll run the program once, stop it, it's fine. A really neat trick is if you have multiple views or different ways of displaying the same set of information, right? There's the spectrum for the signal. If I wanted to do something with that data, sorry, it blacks it out, that's, anyways, let me just do it, there we go. Copy data. You can get custom tweaked versions of your data out of the probe to put onto a blank block diagram as a constant to send to somebody else as the VI, or just manipulate the data yourself. Really neat trick for when you're dealing, like, hey, I've got stuff probed, but I want to mess with the data, but I don't want to edit my custom probe. Guess what you can do? Copy the data out of the probe, and then go ahead and, let's just go ahead and I'm going to do that. Let's copy data, new VI, paste on the diagram, it gives me a constant, gives me that on the front. Now I can go ahead and get that information, right? It's now outside of the probe to do more things with it, right? I would consider that a bit of an accelerator. But rather than show you that, let's talk about code stack accelerators. Let's go once again, transporting data, if you can catch the reference there. So a level 1 implementation of an accelerator, it kind of is that onion analogy, right? If you know that in your debugging process, you've got umpteen windows open, or umpteen 100 windows open, depending on what you're doing, right? There you go, you can already maybe see it's all the way across the bottom, right? And I showed you the, what was it, Oh, Control-Shift-W, right? The all windows thing, right? Let me just get over here, right? I can kind of accelerate to the thing that I want here, but there's still a lot of text on the screen. But if I know I always want to get back to a certain pile of stuff, what could I do for that, right? Well, I use the word corkboard VI, but in general, I could take, if I was like drilling into like modulation toolkit, right? For those of you who are like, I don't know what modulation toolkit is and what Norm's talking about, it being hard to do, so you're kind of seeing it a little bit here. But right, I can drill in like, okay, this is the one that I care about, right? Well, I can go make a new VI, I'm gonna go ahead and save it, I'm gonna call it corkboard, right? For better or worse, you can call it clipboard, whatever. I like the idea, because then I can just go take that. Oh boy, I shouldn't have done that. Hold on. What? Oh, is it because it's a reentrant VI?
I like that.
I thought I kept it hidden, but I guess that's my problem. In any case, so now I have a single VI that's way easier for me to find that can get me to that very specific VI of interest as I'm going through the debugging. And instead of drilling through all the VIs every time, while I'm doing active development, I can just leave this up for myself. Or I could even save this VI off to the side for the next schlub that's going to go ahead and try to be doing debugging afterwards, right? I would say that's an accelerator. You know where probably the problems are happening, especially if you know it's like an architecture bomb going all the way down, right? Well, you don't have to go all the way down, right? You're accelerating that process. That I would say is a really easy corkboard. There's also, you could take that same aspect of it and put it in a VI server constant. Actually, I think I can even do that on that VI. And I do this pretty regularly because then there's no worry of it causing problems in your code stack. If I go to VI server, and you do a static VI reference, right? What is this? So let me go ahead and get back to that here. Yeah, I know, Darren, you're twitching. Right? Now, I have a VI that even has like a little shortcut glyph sitting on it that is not going to ever break my VI, even if there's required inputs, right? It's going to be compiled out of operation. There's no diagram disable structure, and it allows somebody to very quickly get to a VI of interest, and you can even put this right next to, I know you're about to drill down into the code, go here instead, and it'll take you to the thing that you're gonna drill down through. Yes, Fab.
Make sure you add a VI analyzer ignore for unused code.
Oh, really? Okay, so you heard that? There you go. So it is unused code. VI analyzer will throw a flag. And I would say that maybe you just ignore it. Longer side discussion. The other one, which is great, which is really, really great, and actually it's already integrated into the entire ecosystem of our software, which is bookmarks, Octothorpe. That's actually what that is. It's not a hashtag or a pound, it's Octothorpe. You can do bookmarks in your code, and when you open up the bookmark manager, you're going to be presented with a nice little dialogue of places that you might want to get to by double clicking on it, and it takes you straight to that chunk of code. Okay. And I shall move forward. Let's see, once again, the code stack transporters. Y'all saw that within the DQMH tester, there was the ability to open up the block diagram of a VI that was asynchronously running off in the ether, right? That's really nice, right? That's one of the, when Active Framework really hit the market, that was one of these things where I'm like, the fact that I just to get to the individual nuggets that are there if I need to debug them, it was just one of those big barriers to entry for me. And they've gone around, they've done things to help that be easier. But even with that, the idea of, hey, that doesn't make a difference whether it's Active Framework, DQMH has that same thing, right? There's a bunch of stuff running off in the ether. But there are things, not only with the API tester, that allows you to get to that very specific chunk of code, accelerate that process, but also from Zaya Solutions, there's the, no, that's Panther Lab. I'm very sorry, I'm wrong on that one. Let me go ahead and just, Okay, sorry, yes, Panther Dashboard, there you go, that's the difference, sorry. Panther Dashboard is for DQMH, and the functional equivalent for that is Bowser, right? Bowser, okay, there we go. Active Framework Bowser that allows you to get to the code of interest faster that you need to worry about, right? Let's see, so that once again, that's leveraging other people's things that are out there. Now, if you're building your own stuff, great, make your own browser for your own framework. Use whatever you want. Give somebody that ability to get to the things that matter quicker, right? Have some kind of registration process when a thing kicks off. Great. throw its name into a queue somewhere, or a notifier, or an event registration, whatever. I don't care. Just make sure, try to get it registered so that at some point in time, somebody knows one that it's running, ideally, it's great, and then they can get to it faster, an accelerator. Let's see, custom framework, re-entrant register, yeah, okay, time. I got a time, let's see. Oh, I got, okay. All right, data dumps, another one, right? We've alluded to these, it's kind of like logging information is not that different, right? But if you get an error, if you're a level 1 person, you're making a thing, you know that you could possibly, if somebody asks for a negative voltage at here, it's going to have problems. Great, don't send just an error back to your user of error at ni.lv. whatever, right? Give some insight of like, oh, here's the value you asked for. Here's the values that are actually valid for these things, and other actionable insights. I love that, like actionable insights. There's what's needed for that. Logging probes, we talked about it. And then, oh yeah, the unceremonious mother cluster to binary file, right? We're talking about level 1 individuals here, right? We know the mother cluster, the shifter, or the thing that holds all the information of your queued message handler of any sort, has all the information you need. Great. Throw it to a binary file. You're like, wait a minute, I can't read it. Who cares? You've got LabVIEW. Read it. It's usually a type def. Better be a type def. Right? So you should be able to take that current type def, reconstitute that saved information, even if it's like multiple iterations of it, and look at how did it change from iteration to iteration, right? It's like I said, it's unceremonious at best, right? Let's see. Oh boy, what did we talk about? Let's get down all to level 3 once again. Yes, data dumps, diffing tools, yes. So one of the challenges of if you're giving these large data dumps in any domain is figuring out what changed, because it's usually a lot of data, right? Great. Create a tool that allows somebody to go, oh, this changed from there to there, right? Some type of extra, it's accelerated. I mean, that's kind of an accelerator for the insights that you've got, but you need that information first to get there. All right, and we saw this yesterday. I love the fact, I didn't even know that there was a playback mechanism in testeract stuff, but that's really, really cool, right? If you can, recreate the issue. That's what we especially in support, that is a really big challenge for me as a support individual. Something's going wrong with RF. Man, I can get your IO trace log, but that only, I have to start going through it. But I've created a tool that allows me to take an IO trace log and start to script the VIs into existence in the order that they actually went to kind of do a playback. That would be an accelerator to reproduce the issue at hand. Let's see, the idea of I put this in there in terms of class injection, right? If you've got a class hierarchy of things, great. You have the ability to change who inherits from what, and you can kind of insert a parent in between parents kind of situation and change some functionality or add on. Let's see, let's wrap up here, because I think I have to wrap up now. All right, so let's get back to what do we want to provide the future? What, 10 minutes? I thought I had to, I get the whole hour? What, I got 1 minute, okay. I was like, this got real good. But I'm seeing the glazed eyes, so I appreciate it, right? I'm doing a lot of hand waving and so on and so forth. So let's go ahead and tap it up. So what are the two things? Front 6 right here, what do we got? And? Accelerators. Yes, indeed. One more time. Inside. Accelerators. Okay, who's gonna remember it a week from now? Okay, one more time then. All right, now who's gonna remember it a week from now? Beat them into submission, that's the strategy. So I will take just a bit, so that some of you might go like, wait, doesn't this paradigm already exist? And the reality is that it doesn't. It doesn't exist in software. For hardware, it absolutely exists for things like JTAG. There's a lot of people out there, there's a whole paradigm of a design change that facilitates debugging. And then I went and I looked on Google. 27,300,000 results later, 2 hits from the LabVIEW community talking about debugging, 1 general software blog, and the remainder of the hits were about test-driven development, or test-driven design, whatever you say. We have an opportunity here to lead the charge. If you believe this, the bigger problem that you've got out there, that we need to do. We want to change the paradigm of, hey, we want to do this, but we're forced into submission for this. Or, once again, what do you want to give somebody else to do out in the world, right? Let's take that home with us. So hopefully you walked away with a newfound enthusiasm and some skills for proactively augmenting your development with a mindful compassion towards the person who needs to debug your code next, who of course might be you or me or anybody else in this room. All right, thank you all very much.
A special thanks goes out to Kevin Chirey, Quentin Q. Aldridge, Mark Balla, and Jeff DeVore for their help in filming. And of course, this GDevCon NA 2023 wouldn't be possible without all of our sponsors. Thanks.